So today I'm running my algorithmic trading system over here from my iPhone, and I'm going to conduct human brain analysis with convolutional neural networks. So let's get right to it. So I'm going to go ahead and create a new cell. Shift Enter. This is a code cell. So let me start off by importing some libraries. I'm going to do from pillow import image. I need PyTorch, so import torch. Import torch.nn as nn for the neural network features, and import torch.optim as optim, and then import torch vision.transforms as transforms, and then import numpy as np, and import matplotlib.pyplot as plt. Okay, so I'll run that and wait for it to run through the cell. Okay, so we can see Dogecoin has made 50 basis points and Solana has made 36 basis points. Not bad, but it could be better. Um, this is still running. It's setting the environment and loading everything, so I'll let it run. Okay, it ran. So let me backtrack back to home. So I have input images and test cases, and I have the output and the test out. So what I'm going to do is load the data. So I'm going to call this images equals for I in range 52. So there's 52 images. Um, Let me go ahead and make that a generic integer. So I'll call this n equals 52. So this will loop through them to n. So I'm going to come over here and do image dot open f string of, let's see, it's in the inputs folder. Yeah, inputs. So this is going to be inputs slash I dot png. And now that I got that, let me go ahead and transform them. So I'm going to call this, I'll call it tf equals transforms dot compose, and then it's going to have, hold on, it's going to have a list holding the requirements. So it's going to be transforms dot resize. I'll do this to 200 by 200, so 200 pixels, and then transforms dot to tensor. So I'm going to come down here and do image, and I'm going to equal it to tf of u for u in images. Okay. Oh shit, the investments are dropping. Not a good sign. Let's see. Okay, so I've got the images. So let me go ahead and hit Shift Enter. Now let me plot one of these. So I'll just do plt.imshow of images 0. Okay, so this is the brain scan, and I've got to convert these. So this is going to be dot convert RGB. Okay, perfect. So they're now in black and white, so it'll be easier to analyze them. I'll get rid of this. So the next step is to create the neural network. So I'm going to do class. I'll call this brains, and then it inherits neural network module. And then let me go ahead and initialize the constructor. So this is going to be super brains self init. So now I will do self dot process image equals nn dot sequential. So the first one is going to be a convolutional neural network. It's going to have 3 channels and 64 pixels initially. I'll make the kernel size equal 3, stride equals 1, padding equals 1, and then I'll do a relu as the activation function for this layer, and then nn.conv 2d of 64 to 200, kernel size equals 3, stride equals 1, padding equals 1, and then I will do, I'll just keep this simple. I'll do nn.adapt average, no, adaptive average cool 1 1. So now that I have that, I'm going to come over here and do self.classify image equals nn.sequential of nn.linear of 200 to n. N over here for the 52 images. Oh, cool. The coins are going back up. Okay. So now I'm going to do def forward, and I'm going to do self and then x. So x equals self.process image of x. And I have to flatten x for the neural net. So x.flatten 1, and then return self.classify image of x. So a bit about this trading system that's running over here. It's running off my iPhone. So this is an iPhone app that I built, and it's subscribed to a C++ WebSocket server and trader that's hosted on the cloud. I'm like stress testing it now. I'm in the phase where I'm trying to figure out how much does the cloud cost relative to like the algorithms running on it. And it's going to be very important. This is a very important step for me before I move on in my algorithmic trading journey. But yeah, so okay, so this is done. So now it ran. So to test this out, I'm going to do model equals brains, and then I'm going to do model, and I'm going to pass the image 0 dot, and I'm going to unsqueeze it to match the channel. Unsqueeze 0. Okay, so there's an error. Oh wait, did I get this part wrong? Is it average? Is it average adapt? Oh, perfect. Okay, yeah, it was 2D. I forgot the 2D part. Okay. So I'm gonna do model equals brains, and then I will do criterion equals nn dot cross. So we're gonna use cross entropy as our loss function. So entropy. Oh wow, I didn't even write that part right. Is it cross entropy loss? Yeah, it's cross entropy loss. Okay. So then I'm gonna do optimizer equals optim.atom of model.parameters. Learning rate equals learning rate. So let me go ahead and change the learning rate over here. I will do it as learning rate equals 0.001, or I'll do 0.5, and then epochs are going to equal 100. Um, damn, these is coming down a little bit. Hopefully it keeps going. Okay, so I got everything set. So what I'm going to do now is come here and do for epoch in range epochs for picture in image. This will be I'll call this y out equals model, or I'll call it y hat equals model of picture. Wait, is that what I called it up here? Yeah, image. So picture dot unsqueeze 0, and then this is gonna be y out equals torch. Oh, right, for the class. Oh shit. Yeah, I had to load the classification. Okay. I'll go ahead and just do that here. So I'll do y equals open. What's it called? Output.text. Output.text. Read lines. And let me print out y. Okay, so they need to have the character sign replaced. So I will do list map um, lambda of IE, and I'm gonna do these can be integers, so it'll be IE.replace back character, and then comma, close this off, close this. Um, Oh, okay. That's why I had to do float. Perfect. They're all loaded in. Um, okay, so now that I got that, let me refresh that. Um, Let me go ahead and refresh this. So this is going to be torch.tensor of I d type equals torch.long. So I'm going to do I and I'm going to add enumerate. Yeah, enumerate's so handy in Python. Oh shit, these went up a little bit. That's good. Okay, so enumerate is there. So then I'm going to do optimizer.zero gradient. Um, Loss equals criterion of y hat y out, and print loss.item. Break this loop, run it. Perfect. Just to make sure it works. So then this will be loss.backward for back propagation, and then this will be optimizer.step, and then let me declare a variable up here called the loss equal to 0. So then this will be the loss plus equals loss.item, and then over here I'll print f string of epoch plus 1, loss, the loss, and then run it. Okay, so this might take a while. Well, I've got the algos loaded up here, so it's like we can watch that for entertainment. But yeah, let's okay, I don't want this training to take like an hour. Let me go ahead and stop this cell. Okay, so I'm gonna make 0.001 the learning rate. Let me change around some of these pixels. So I'm gonna do 128, 128 over here, 128, 128. Yeah, I'm gonna rerun the whole book. Okay, so I'll change back the learning rate to that, but I'll make the epochs 35. I mean, it's not gonna be perfect either way. I just want to show like the whole process. So let's see, kernel. All right, so restart kernel. So let's recompile this from scratch. Okay, so it doesn't seem. Okay, run that. Okay, that ran. Run that. Run that. Wait, did the model compile? Yep. Run that and train. So let's see if the training is any better on this. Okay, it's much quicker. I have 35 epochs, so okay. So let's see. Solana has made 46 basis points so far. Dogecoin has made 47 basis points, but they've kind of fell. Um, the neural net is activating on there. Oh, that's the crazy thing. This fucking iPhone app over here has 49 neural networks working together to like read all of the order books and see if there's patterns in it. So there's a lot going on right now. Okay, 8 epochs, 9. Algo trading and brain analysis. To think this all started off with me like just fucking programming a loan table in Excel, and now it's like I'm on this level. I mean, no. Don't get me wrong. There's a lot that I have to learn, but I've made it pretty far. I'm happy for my success with this. Um, Damn, that's Dogecoin's just stuck on 47 basis points. Um, I think out of these two, I think I might have a higher chance of making money with Solana. I don't think Doge might drop. Oh, as soon as I said Doge might drop, Solana just dropped. All right, I'm gonna shut up. Okay, it's 21, 22. So we can see like the loss is being minimized. So like the neural network is doing its job. Um, but well, it kind of the loss kind of went back up and curved back down. Yeah. Oh, now they're both dropping it. Shit. Shouldn't have said nothing. Okay, it's almost there. 5 more left. And it is trained. Okay, so now I need to open the test images. So test images equals, and there's 8 of them. So that's going to be in test cases. So it's going to be image.open f string of test cases i.png for I in range 8. And then test image equals tf of u for u in test images. And then test output is going to be open. Let me come back over here. Test out.text. Okay, so read and then test out. Okay, just replacing the characters again. So it's going to be list map lambda IE integer of IE, or no, I'll just do float of IE dot replace. Uh, backslash n with nothing. Oh wait, no, that wasn't supposed to do that. Okay, comma there, and then close that off. Okay, so actually, yeah, I was gonna do a float. Okay, um, so now what I'm gonna do is for I picture in enumerate test image. I will do well. I want to plot these, so it's gonna be wait, do I have matplotlib up here? Let me just double check. Yeah, I got matplotlib. So this will be figure equals plt.figure ax equals fig dot add subplot of 2 by 4 by I plus 1 for I in range 8. And then it's going to be ax dot imshow, or rather, let me make the predictions first. So with torch.noGradient, so this is not going to modify the neural network's weights. It's locking them just so I can test it. So I'm going to call this test out equals model of um, picture dot unsqueeze 0. And then over here, I will do, let's see, C1 equals torch dot softmax of test out. Dim equals 1. And then P1 equals torch dot argmax of C1 dim equals 1 dot item. And I'm going to print P1. Okay, there was an error. Oh, I forgot. This has to be dot convert RGB. Okay, so I got the classifications. So this will be actual equals um, test out of I. and this in um oh okay, there's a little oh shit. Let's see. Okay, I'm not fucked. I'll call these names equal, or I'll call this diagnosis equals um normal, tumor, trauma, and schizophrenia. Okay, so this will make it look cleaner. So then I will come over here and do diagnosis, or rather, how can I do this? Index the. Oh shit! I didn't even look at the algos. Solana dropped. Dogecoin's kind of coming back up. Okay. I'm trying to think. This is like test out. Because this. Hang on. Let me. Okay. Instead of just sitting here doing nothing, let me go ahead and print actual. Okay. So, um, I need to somehow get this. Oh wait, what am I doing? Oh my god. This has to be the into. Okay, I just had a brain fart. Okay, so I'll call this UU. I'll call this VV equals the integer of P1, or rather Y of P1. Because if we remember, Y has all of the classifications for the training data, so we're just gonna index that. So UUVV. Okay, so actual will equal diagnosis of UU. Predicted will equal diagnosis of VV. And then title will equal F string of actual, or no, predicted. So predicted, and then actual, actual, and then I will do ax.set title of title, ax.imshow of test images of I, and then plt.show. And before I forget, let me also spread some of these plots out. So I'm going to do from matplotlib import rc params, and that is going to be rc params of figure.auto layout equal true. So let me run this. Oh right, I had to index the plot as well. So this will be ax of I, and here we have it. Okay, so for this brain, it predicted that it has trauma, but it's a normal brain. For this brain, it predicted it has a tumor, but this is a normal brain. For this one, it predicted a tumor. It actually has a tumor. Tumor. Okay, those are good. This predicted trauma, and it's actually trauma. Predicted trauma, actually trauma. But this predicted trauma, but it's actually schizophrenia. And this predicted trauma, but it's actually schizophrenia. So yeah, that's oh shit. This is at 50 basis points now. But yeah, that's about it for that. I know this is like a shift in content, but I mean, it's very interesting. So I've been working with this kind of stuff, so I wanted to share it. So yeah, I thank y'all for watching my video. I'm gonna keep coming out with more and more good quant content, so stay tuned. Peace out.